So this is question number 2.3, and the question says ki depict the galvanic cell in which the reaction Zn solid plus 2 Ag plus aqueous gives Zn2 plus aqueous plus 2 Ag solid. Takes place further shows which of the electrode is negatively charged, the carrier of the current in the cell, and the individual reaction at each electrode. So once you know the basic of galvanic cell, then you can easily do all this problem and solve all this problem, right? So what is galvanic cell? Galvanic cell contains two beaker and two electrodes in it connected by wire and having its own electrolyte in it and a salt bridge that connects the two beaker, right? Simple. So what happens here is we take one electrode of one metal and the other electrode of another metal, and the metal that I have taken, the same metal electrolyte I have to take, and from here the metal I have taken, the same metal electrolyte I have to take. Now reactions happen, oxidation at anode, oxidation at anode, and reduction at cathode. Simple. So you can also remember that by a trick that is called anox, and red cat. Means at anode oxidation occurs, at cathode reduction occurs, right? So this never changes for irrespective of any cell you talk. This will happen at anode, oxidation will happen, and at cathode reduction will happen, right? Now after that, a important concept is cell representation. So I want to also complete all the concept that is around this. So the cell representation is done by representing left side anode and right side cathode. So you have to do like this. So here you can see that Zn is taking giving electron, right? That's why it is getting positive. So because it is giving electron, so giving electron is called oxidation, and taking electron is called reduction, right? So that's why at anode oxidation is occurring because Zn is giving electron. That means oxidation is occurring, and that means it is anode, right? So anode is left side anode I have to write, and right side cathode I have to write. In the middle I have to give two line that is that represents salt bridge, and that is the separation for metal and its electrolyte and metal. Like this you have to write. Okay, so now once I know that at anode oxidation is occurring and at anode Zn is present, that means I will write the Zn solid, then Zn2 plus aqueous, that is electrolyte. Then I will write in reduction cathode is at cathode reduction is occurring, and at cathode I have Ag plus to Ag. So aqueous plus aqueous plus is going to Ag solid. So that's why you have to, that way you have to write the electrolyte then the metal, right? Simple. Cell representation clear. It will come in exam. That's why I am like remembering this or revising this concept to you guys. And also cell is cell, electrolytic cell, how you represent it? It is standard reduction potential of cathode minus standard reduction potential of anode. That is representation of E naught cell. Okay, now let's come to the question. So first question, what it says ki which of the electrode is negatively charged. So for that you have to remember that for galvanic cell we have two cell, galvanic cell and electrolytic cell, right? In galvanic cell what happened, we have two beakers and two electrodes. In electrolytic cell what happened is we have two electrodes but in the same beaker. So electrolysis happens here, and electroplating happens here. So this is the two thing that you have to learn in this chapter. And particularly here what happens in galvanic cell is your it converts electrochemical energy into electrical energy, but it takes electrical energy and convert into chemical energy, right? So for that, one thing that is difference in it is the anode and cathode charges it contains. So at anode, suppose it is anode and it is cathode, it is anode and it is cathode. Okay, so what do you think, what is the charge that is going to be on this anode, positive or negative? and what is on this anode, positive or negative. It is going to be different for both. It is opposite. So once you will remember for one case, you can easily predict the other case. So for that I have a trick, panic, PANIC, that is for electrolytic cell. For electrolytic cell, so for panic means positive at anode, right? So positive at anode, you have to remember this, positive at anode. Okay, then what you know by this mnemonics is that positive you have to sign give to anode. That means this is going to be galvanic cell is going to be opposite of this. That means at anode here it is negative, and because at anode it is negative, that means in galvanic cell cathode has going to be positive. And also similarly here, because anode has a positive, that means cathode has negative. So now you can easily remember this sign by using this mnemonics, panic. Okay, so now you can say that at anode the electrode is going to be negatively charged. That means at anode oxidation is occurring, and oxidation is occurring for zinc. That means zinc is going to be negatively charged. Okay, simple. First question done. Second question is the carriers of current in the cell. So in external circuit, E flows from Z to Ag. That means anode to cathode, because E is generating here. E is getting generated here. So much E is generating here. That means, and so much positive is generating here. That means E will move from there to there. Our current will move from positive to negative. Simple. Electron will move from anode to cathode, and current will move from cathode to anode. Simple. So electron will flow from zinc to Ag. Simple. And in electrolytic bridge, here what will happen in this electrolytic and salt bridge, the cation will move toward cathode. From cation, here the cation will form, it will move toward cathode, and anion that is going to form here, that will move toward anode. Okay, so this way it is going to occur. And in the third question, what they have asked is write the individual reaction at each electrode. So half reaction they want to know. For anode, it is oxidation is occurring of Zn. Zn, so Zn solid is going to be Zn2 plus aqueous plus 2 electron. And at cathode, what is happening? 2 Ag plus aqueous is getting 2 electron and becoming Ags solid, right? So these are the thing that is essential for understanding the galvanic cell. And this question is regarding that basic concept. You can also see it in mind map that I have made here. In mind map, you can see that there are 1 2 3 4 5 and 6 main topics that is in chapter. And this particular question is asked from electrochemical and galvanic cell. And in galvanic cell particularly, the topic is galvanic cell depiction, like representation, and then where the charge is present, at a node what charge will present, and then from where electron is moving to where, and write the half cell reaction. So it all came in galvanic cell depiction, and particularly in the main topic galvanic cell. Okay, so you can also see the mind map. It will make it easier to remember the concepts. Okay,